I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We are serving you for the last 15 years absolutely free videos. More than 16,000 of them are there for you. Let me thank all the viewers and subscribers for watching my videos, posting excellent suggestions, and some beautiful questions. So, here is a request from our subscribers. They need to understand and master exponential functions. In this series, we have taken many examples for them to master these exponential functions, and in this video particularly, we'll have 20 questions to understand how do we find increasing and decreasing interval for the exponential functions. So here we'll consider exponential function of the form y equals to ab to the power of x plus c. Of course, you know a is never equal to 0, b is also not equal to 0. However, b should always be positive, right? And b, the base, should not be also equal to 1, right? If b is 1, then it is not an exponential function, it's just a horizontal line. And that is why we have this restriction also that b is not equal to 1, right? Now, in this video, we'll focus on one parameter, and that is increasing or decreasing. Sometimes we write increasing or decreasing interval. However, you know, exponential functions do not have any restrictions. They are either increasing or decreasing, right? They could have a minimum or a maximum value, right? You know, if we restrict them, right? But if we don't, then it is always greater than some value, right? We have a horizontal asymptote to look for. So let's begin with the equations and try to understand the concept as such. The very first one here is write if the graph of the function is always increasing or decreasing, right? So the very first one, y equals to 8 to the power of x. Now 8 is greater than 1. This function will be always like this, right? So it is always increasing, right? Right. So I will write I for increasing from now onwards. Is that okay? Now the second one is minus 3 2 to the power of x. Now minus, what happens with that? Minus makes it reflect on the x-axis, so this becomes decreasing. You get the idea. So this is decreasing. So I'll write D for decreasing. Perfect. Now, I would like you to pause the video, answer these questions, right? There are 20 of them. First 15, just practice and then test questions. Now, here we have a variation to this. We have y equals to 7 times 5 to the power of minus x, right? So look at this minus. Now, this minus, we have 5. 5 to the power of minus means it is as good as writing y equals to 7 times 1 over 5 to the power of x. Makes sense? So definitely this is decreasing, so I'll write D for decreasing. You see how? So these are the variations which you have to look for. So if the value of B is greater than 1, in that case it is increasing, but if we have negative outside, that means A is negative, it is reflected on the x-axis, so it becomes decreasing. Also the exponents, if it is negative, the sign reverses, right? Okay, now we have 4, which is y equals to 4 over 3. Now 4 over 3 is definitely greater than 1, and therefore this will be increasing, so I'll write I. And now we have 5 times half to the power of x, which is decreasing, and therefore I'll write D. So I hope the concept is absolutely clear. Now in these examples, we have focused mainly on y equals to ab to the power of x. And in all these examples, we have a horizontal asymptote, which is y equals to 0, right? So it is decreasing or increasing from 0, okay? Just in case you need to figure out the interval for the range, right? Okay, now here is another set of five questions. Now we are taking the equation as y equals to ab to the power of x plus c. And remember, b is not equal to 1, correct? Perfect. So the first one is y equals to 3.50 to the power of x minus 2. Now, in these examples, I like you to also tell me the range, right? So, also include range. Perfect. So now, as you can see, the function here is increasing, right? But we have minus 2. And therefore, it increases from minus 2 to infinity. So you could write minus 2 is not included, but it goes to up, right? So like this, and therefore, it is increasing. So now, I'm actually including the range also. Many times, the range is to be included in the characteristics of the function. Find it interesting, right? Now the second one here is, which is question 7, 2 times 0.75 to the power of x, which definitely is decreasing. And since it is decreasing, we know it is from, range is from minus infinity to 0, right? So it is decreasing. Makes sense. So likewise, you can now complete and answer these questions. In case you want to learn from me, feel free to send an email on the address given. Most of our students, they start with basics, but they are the best and they get to know how do we solve the most difficult questions in a competitive exam. So, follow us also on the globalmathinstitute.com website for the latest updates. Let's continue with our exercise of increasing and decreasing interval y equals to half times 1.5. 1.5 is greater, so this is going to be increasing, and that is from 0 to infinity, and we'll write increasing. Making sense, right? So, of course, it makes more sense to include the range. Perfect. Y equals to 3 times 1.2, but the power here, note, is minus, and therefore it is going to decrease, right? And therefore it is from minus infinity to 0. It is good practice to write the lower number first, minus infinity to 0 instead of 0 to minus infinity, correct? Makes sense, right? So decreasing. Now we have minus here and minus 3. So the whole equation has been split as minus 3 also. As because of minus, from minus 3 it further goes down, and therefore the graph of this will be decreasing, and the range is going to be from minus infinity to minus 3, right? So it will be decreasing. You get the idea. This minus 3 is because of minus 3 written here. Perfect. Now, here is the set of five more questions for you. I'd like you to now pause the video. You've understood all the strategies and try to answer them along with me. Note 11, 3 to the power of minus 2x plus 2, right? So that minus makes it 1 over 3, and therefore this has to be decreasing and decreasing from 2, right? So what I'm trying to say, it goes to minus infinity and comes up to 2, right? That is what it means, right? The next one here is 1 minus 7 pi. Now, you know, pi is 3.14 greater than 1, right? So, so it should be increasing. However, that negative reflects it down, right? So from 1, it is reflected down, right? So it will be minus infinity to 1, and this will also be decreasing, correct? Let's look into the next one, which is minus 2, 1.25 to the power of minus x. That minus x makes it 1 over 1.25, therefore it should be decreasing. However, we have a negative sign here, and that makes it reflection increasing, right? And that from 0 to infinity, right? So it could be tricky. So carefully look at the equation and then answer. So minus means reflection on the x-axis 3 by 2, but the power is again negative. That means be 2 over 3. So decreasing becomes increasing. You get the idea? So instead of decreasing, it will get reflected, and therefore it will be increasing. So this will again be increasing, and it will be increasing from 0 to infinity. Now we have minus 2 half to the power of minus x, You would also write this as y equals to minus 2, 2 to the power of x. You get the idea. So if you add this particular step in between, it makes more sense. So because of minus, it gets reflected. And so what do you notice here? That this will be decreasing, and therefore the range will be from minus infinity to 0. So whenever it is decreasing, you should write from minus infinity to the horizontal asymptote. Horizontal asymptote will not be included, right? It is a value which is approached by the graph of the function but never reached. Now that brings us to the end of this particular session on trial, right? That is practice, getting the concept, and brings us to the test part of it, right? So now, can you tell me, answer these questions, right? One by one. Only five for you. So the very first one is y equals to minus 6, 2.25. So minus makes it reflection, and clearly it is decreasing. And whenever it is decreasing, we are writing from 0 to, sorry, we are writing from minus infinity to 0, right? And is decreasing. Makes sense, right? Next one. Next one, we have minus 4, right? So horizontal asymptote is at minus 4. However, the function is increasing. So the function is increasing from minus 4, and therefore it will be from minus 4 to infinity increasing, right? Now we have 2.5 to the power of minus x. We could also write this as y equals to 2. Zero point 0.5 is half, right? So if I do the reciprocal of that, I get 2 to the power of x. You get this idea? So it is increasing from 0 to infinity, right? So it is also increasing. Next one here is minus. So you could write this as y equals to minus 3, 2 by pi. Now 2 by pi is less than 1 with x as the exponent, and but this makes it increasing. So this is also increasing from 0 to infinity. The last one for you, 6 minus 2 to the power of minus 3x. So you could write this as y equals to 6 minus half, right, to the power of 3x. You get the idea. So decreasing reflected means increasing, and increasing from 6, and therefore it will be from 6 to infinity increasing. Does it make sense to you? So, with that, we come to an end with this beautiful exercise of understanding when will the graph of this exponential function increase or decrease during its whole interval when x belongs to real numbers, right? So, very clearly, you have to just take care of these numbers. The value of a, which could be negative, will reflect it on the x axis, correct? And x, it could be negative, and also reflection on the y-axis makes huge difference. Change is increasing to decreasing, right? So both reflections, whether it is reflection on x-axis or on y-axis, change is increasing to decreasing. Perfect. With that, we come to an end of this particular exercise, and I hope you understand and appreciate it. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thank you, and all the best.